Question 3 involves an experiment to determine absolute zero using a flask of air. In 3.1, we're to explain why the volume of air in 9C is less than that in 9D. Well, the gas is at a greater pressure in 9C as pressure increases with depth in a fluid, and as the temperature is constant, so the pressure times volume will be a constant. As pressure goes up, volume goes down. In 3.2, we're to explain why Charles's law can be applied to compare the air in 9A with that in 9D. Well, Charles's law applies as both have the same mass of gas at the same pressure. In 3.3, we now have to explain why volume 1 and volume 2 can be determined, identifying a suitable measuring instrument and explaining a suitable procedure to eliminate possible systematic error. Well, we'd measure V1 and V2 using a measuring cylinder. We'd ensure our eye was level with the bottom of the meniscus. This avoids parallax error. In 3.4, we need to add the data to the graph, and just running through a few of the details with the graph. The x-axis is done for us already. That is theta in degrees C. This is going to be volume in cubic centimetres. And what I've done, I've started at 180 and I've made it clear that this point is labelled at 180. I've then made sure I've got a sensible scale, so that is then 190 and so on, and that then takes me up to 260. I won't do the whole lot. Just make sure you have a sensible scale going up in 1s or 2s or 5s or 10s whenever you're doing a graph axis, and make sure you show that this is not naught. And also make sure obviously you label the axis with the quantity and the unit. Okay, then at 19 degrees C, the volume is going to be at 255 minus 48. If there's 48 cubic centimetres of water, there are 255 cubic centimetres in total. So that is the volume we have, which is 207. So that's one of the points, 19 and 207. Then for the other one, we have 86 degrees, and that is the full 255. And do make sure you plot those accurately to within plus or minus half a square. 3.5 is just adding a best fit line to the graph. Do make sure you use a clear ruler. Do make some time to ensure that you have the same number of points above and below the line, and make sure that the line is not doing this kind of thing. If I do that kind of thing, if I do that, I've got the same number of points above and below the line, but the line is clearly too steep. Okay, so do be careful with your lines of best fit. For 3.6, we need to find absolute zero. Well, this is theta when the volume, for 3.6, we need to find absolute zero. And this is theta when the volume is equal to 0. Firstly, I'm going to find the gradient, and I'm going to use as big a triangle as possible. I'm going to show all my data on the graph, and I get 260 minus 195 over 94, which is 0.69. Then, from y is equal to mx plus c, c is equal to y minus mx, which is 260, just taking some values, minus 0.69 times 94. This comes out at 195. Then I can find when y is equal to 0, x is equal to minus c over m, which C I had as being 195, so it's minus 195 over my gradient of 0.69, which gives me a value of minus 282 degrees C.